If you are watching this, you are probably seated somewhere else. You may consider yourself at rest or not in motion. What if I say that you are not at rest at all? Right now you are sitting on a chair on the Earth's surface near the equator. At the moment, you are spinning with the Earth covering a staggering 1,700 kilometers an hour. As Earth spins, it also revolves around the Sun. How fast? Blazing fast at 107,000 kilometers an hour. Our Milky Way galaxy is moving across the universe at 2.1 million kilometers per hour. As you sit there watching me, you are actually traveling that fast too. If you look at motion into a scale this grand, there is practically no difference on your speed when you drive a sports car or a vintage old bag. Everything on Earth is moving through the vastness of the universe at almost equal speed. Insert relative motion. To us, Earth seems to be stationary. In most physics problems, we usually describe motion relative to the Earth's surface. By doing so, we assign Earth as our inertial reference frame. This is a thing that we pretend to be stationary where we relate motion into. We describe motion of objects relative to the inertial reference frame. If we treat Earth's surface as our inertial reference frame, it is meaningful to say that this rocket ship is moving at 11,000 meters per second relative to the Earth's surface. Inside the rocket ship though, as it moves constantly at 11,000 meters per second, it will feel like it's not moving at all. Instead, it will look like it's the Earth that is moving away from the rocket ship at 11,000 meters per second. At this moment, the rocket ship became our inertial frame of reference that is standing still and everything is moving around it. It is strange to hear that the rocket ship is stationary, but so is to say that the Earth is not moving either. Motion is never absolute. It is always relative to an observer's point of view. Imagine that you are this guy. You toss a ball upward and caught it. To your point of view, it went straight up, then down. But to an observer by the roadside, the ball followed a trajectory. It is because of the horizontal velocity of the car and the upward velocity when you threw it. You cannot argue that your observation is correct and the guy from the sidewalk is not. Both of you are correct. In fact, if there are 5 more people observing the ball, they will all see differently. Always remember that motion is never absolute. It is always relative to an observer's point of view.